I had a question from a student in regards to section 11.5, and their questions were over two problems, number 3 and number 6. And so I'm going to answer those questions. So I just wrote it out myself. A game costs $43 to play, and that game's rolling a pair of dice. And you get 6 times the sum of the dice. They want to know what's the expected payoff, and they also want to know, is it fair? And so we know what to do if we've watched the videos. We go ahead and we list the outcomes. Now, the outcomes that could happen if we're rolling a pair of dice and we're looking at the total, right? We're looking at the sum on the dice. It could be as low as 2. It could also be 3, 4, 5, 6, 7, 8, 9, 10, 11, or 12. And here we're going to have the money value, right? The profit. Always profit in expected values. So that's going to take a little bit of work, but based upon our past work, we can know these probabilities. So they're using examples that they've used throughout the sections. And so here's where I find whether somebody's been really understanding those probabilities. So I talked to somebody today and they had no problem knowing that this was 1 out of 36. This was 2 out of 36. Rolling a 4 is 3 out of 36. They asked them about the 5 and they said it was 4 out of 36. 6 would be 6 out of 36. 7, 8 out of 36. 8 is, 7's not, apologize. I have something wrong in there. So 1 out of 36, 2, 3, 4. This is, just kidding. I knew 7 was my highest. This is 5 out of 36, 6 out of 36, and then 8 goes back down to 5 out of 36. 9 is 4 out of 36. 10 is 3 out of 36. 11 is 2 out of 36. And 12 is 1 out of 36. And I had another student that was on the Zoom session. He says, well, how do you know those? And it's because they were already invested in the problem. They knew that the space was 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, and 2, 6. 3, 1, right? This is done sections ago. And you used it in the OR probability, like I know, because I answered some questions about it with students. And then it's 4, 1, 5, 1, 6, 1, all the way down to 6, 6. And we get this grid, right? And so why does 8 go down to 5? Because there's only 5 ways to roll an 8. They are 2 and 6, 3 and 5, 5 and 3. Oh, sorry, I've skipped one. 4 and 4, 5 and 3, and 6 and 2. Only 5 ways. And so they already are invested in that sample space. And so they got those probabilities just fine. And so my goal in this is to guide you through this problem. Let me do this a little bit differently. Let me get a pixel eraser and it will go through there. So what do we have to do? We have to determine our profit. And so what do we know? We get paid 6 times the sum on the roll. So if I rolled a 2, I would be paid $12, right? And so one mistake is for somebody to put the $12 in here. That is not correct. And the reason why is that's not your profit. Remember, it costs you something to play the game. And so it's not just $12, it's 12 minus 43 that it costs you to play. You're going to actually lose money if a 2 is rolled. How much are you going to lose? You're going to lose, let me switch that back to object eraser. You're going to lose $31. And make sure you mark it as a loss. For this second one, 3 times 6 is 18, minus the 43 it cost you to play, negative 25. 4 times 6 is 24, minus the 43 it cost you to play is negative 19. Again, for this 5 one, I'm going to take the sum of the on the die is 5. I'm going to get 6 times that sum, but I got to subtract away the 43. So 5 times 6 minus 43 is 30 minus 43, or negative 13. 6 times 6 minus 43 is going to be a negative 7. 7 times 6 minus 43 is a negative 1. 8 times 6 minus 43 is going to be a 5. That's the first time we actually make a profit, is when we collect $48 after spending our 43. 9 times 6 minus 43, 11. And I really feel like this was already done in the video. It feels familiar, but the question still came up. 17, 11 times 6 minus 43, 23, and 12 times 6 minus 43 is 29. So all that's left to do is do your expected value. You got to take the x times the p of x and add them all up, right? You're going to add up all those x times p of x's. So you're going to have your negative 31 times your 136 plus your negative 25 times your 2 out of 36. And that will give you your expected payoff. And then is it fair? It's only fair if the expected payoff is 0. So you can answer that it's whether that's true or not. But we'll leave that calculation to you. Just the setup there is all that was needed. Number 6, very much the same thing. We're going to flip 3 coins, and you're going to be paid 6 cents if it's 3 heads, 4 cents if it's 2 heads, and 2 cents if it's 1 head. And so again, we need to know, hey, what are the outcomes? So remember what we did here? Outcomes. We're going to do outcomes here. Now these outcomes aren't our x's. Our x's is always our profit. That's what these problems are all about. And then it's associated probability. Now this should be a very familiar setting from the earlier sections of chapter 11. We know the outcomes are, hey, you get 3 heads or 2 heads, like they're mentioning, or 1 head. Now they don't mention this in the wording, but you could also get no heads. Now how do you know that? Because you've done this problem before. You looked at this setting before, not this problem. And so the wise person that's been through the homework, that remembers the things, knows that this is the same as having 3 children. It's the same as the flipping 3 coins that we've done before. You may have flipped even more. But when it was 3, it was 1/8, 3/8, 3/8, and 1/8. And you're like, what are you talking about, Jensen? I don't remember that. Well, then you are not thinking right. If you're flipping 3 coins and you want to know these things, just like for this problem, you need to see the space. Just like for the problems that involve 3 coins before this section, you need to see the space. Well, see the space. Heads, heads, heads. Let's put a single tail in there and move it to the different positions, keeping heads in the first one. Those are the ways to flip the coin getting heads the first time. Let me be methodical. Sorry. Tails, tails, tails. Let's put a single heads in there. And let's put that heads in a different place. And let's do 2 heads with that tail in the beginning. There's your 8 outcomes. That should seem very familiar from what you did before. How many have 3 heads? Just 1. How many have 2 heads? This one does. This one does. This one does. That's where the 3 comes from. Right? So 2 heads. How many have 1 head? Let's do that in green. 1 head. Here's 1 head. Here's 1 head. Here's 1 head. That is why they have 3 there. And the one that's not shaded is the one time you get no heads. And you have to take that into account, even though they don't mention that at all as an outcome. So let me get rid of these highlighted things. Let me get rid of all this down here. But that's all background work that you should know or have experience with, right? And then we got to go to what's currently in this section. So these outer columns are ones that we worked out before. It's this middle column that's unique to this section. And so our profit, they want to know, is it fair to pay 4 cents? Well, let's pay 4 cents. If we pay 4 cents and we get 3 heads, well, 3 heads would be pay us 6 cents, but we got to take off the 4 cents. 2 heads would pay us 4 cents, but we got to take off the 4 cents. 1 head would pay us 2 cents, and I got to take off the 4 cents because that's what it cost me to play. And 0 heads is not mentioned, so evidently I don't get any money, and I got to take off the 4. And so going in here, you can back up the video if needed. you know that you get a value of 2 out here. You get a value of 0 out here. You get a value of -2 here. And you get a value of -4 here. So what do we do? I can do this one for you. I skipped it up top from time perspective because at this point it should be nice. Well, we got 2 times an eighth plus 0 times 3/8 minus 2 times 3/8 minus 4 times 1/8, right? X times p of x. And the latter two are x's were negative, so I'm just going to write it like that. I'll keep everything in eighths. That's 2/8 plus nothing minus 6/8 minus 4/8. Okay, so 2 minus 6 minus 4 is -8. That's -8/8, which is -1. So the expected value of this problem is -$1, right? That everything was in, -1 cent. Everything was in cents. Apologize. You're going to lose 1 cent as a player. Is it a fair game? No, it's not fair. Why isn't it fair? Because the expected value isn't 0. 0 would be completely fair. Negative means it's disadvantage to the player, and positives means it's disadvantage to the person who's running the game. And sometimes that's a casino. They're never going to have it not fair in that direction. So it's not a fair game because the expected value isn't 0. It's -1 cent, but that's how you do it. You rely upon, and I'll highlight it again, you rely upon your old skills, right? They had some questions in there in the OR probabilities and the straight probabilities about flipping 3 coins. Same probabilities. And then what's new for us? This stuff that I'll circle, this is new. Running the formula is new for us. But we have that strong foundation. So hopefully this helps. Thanks.